Hello, everybody, and thank you for joining us for today's webinar, Ecological, Silvicultural, and Cultural Considerations for Ash Preservation in a Northern Forest. My name is Kate Four, and I'm with the Vermont Urban and Community Forestry Program, which is a collaborative program between UVM Extension and Vermont Department of Forest, Parks, and Recreation. Today's webinar is the last in our Forest Pest Outreach webinar series and is offered in partnership with the Agency of Agriculture, Food, and Markets. Our presenter today is Dr. Tony D'Amato, who is a professor, director of the forestry program, as well as a director of research forests at the University of Vermont. We're fortunate to have him join us today to share his expertise, his research, and his experience in thinking about maintaining ash on the landscape in face of both climate change and emerald ash borer. Before I hand the mic over to him, a few reminders and logistics for today's session. Your microphones will be muted during the presentation. However, we do want to hear from you, so please go ahead and put your questions in the question box, which you can find on the side panel, and they'll be addressed at the end of the presentation. Today's webinar is being recorded and will be available on the Vermont Urban and Community Forestry YouTube channel for future viewing. And if you've missed our other past two webinars, one on jumping worm and one on hemlock woolly adelgid, you can also find those on our YouTube channel. I'll go ahead and put a link to the YouTube channel in the chat box after we get rolling here. Today's presentation is approved for one SAF continuing education credit. So to request that certificate of attendance, please go ahead and complete the survey at the end of the session. So I think that's it for me. And with that, I'll go ahead and hand it over to you, Tony, to get started.
Thanks, Kate, and thanks folks for logging in here and really appreciate you making the time for this. And as Kate mentioned, certainly I'll try to share some of my perspective, but more importantly, I'm fortunate to get to share perspective of many others that I've been able to learn from throughout this challenging time dealing with the threat of emerald ash borer. And those folks are listed here, as well as many others who have really contributed to what I'm going to talk about today. And so I've been presenting a lot on different aspects of thinking through sustaining ash in the context of emerald ash borer. And really the request associated with this webinar was specifically around kind of thinking a little bit outside the box, in that if we truly were to try to preserve ash in the forest or preserve elements of ash, how might we do that? And so I'll certainly draw upon some of the things we've talked about in the past as it relates to keeping future options for ash using silviculture, but I'll also dig a bit into other techniques related to insecticides, biocontrols, integrated resource management that really thinks about ways that we can sustain ash as an option in the future, both from a regeneration standpoint, but also a mature tree component. So what I'll go through is just some context. Why are we talking about this? What's the opportunity in front of us as it relates to preserving ash? And then get into why would we even think about preserving ash? What are some of the goals that we might be achieving with preservation? And then I'll finish up by really getting into the details as to what is the current state of our understanding as it relates to treatments that actually exist for preserving ash out in forested settings. So just a reminder for context, depending on where you're logging in from, if you're particularly in the Northeast, at this point in time, you're in a state that has emerald ash borer in it. And so with that, we often look at ash very differently than we did prior to it showing up in the region. It really is kind of on the front of our brain when we're looking at ash. But it's worth just reflecting on just how new an arrival EAB is to the Northeast relative to other parts of the US where EAB has been present for, in some cases, over a couple of decades. So if you look at this map from 2016 of known EAB detections, at that time we were relying on Vermont's exceptionalism, I guess, to keep EAB out. Certainly Maine, the way EAB should be, I think was their motto at the time, keeping it out. And those really, for a little while there, gave us this false sense of hope that maybe certain states might not see this insect. But at this point, it's pretty clear that emerald ash borer spread is pervasive. It continues to expand both within the states it's already been detected in, as well as into new areas. And so when we think about ash in a forest, it's certainly a very threatened resource. So far as much in other parts of the ashes range, like in Canada, it's been declared a threatened and endangered species, just given how we feel about the future of that. And so when we're looking at ash in the Northeast, given that emerald ash borer is still fairly recent to the region, there are lots of areas that still have mature, healthy ash. It's very different than what people in Michigan are dealing with in those landscapes, and certainly other parts of the Ohio River Valley. And so when we're looking at our forest and thinking about emerald ash borer, we're dealing with a very different context than others that were already dealing with mass mortality as that species was working through the Midwest. And so it provides some options and some opportunities that really haven't been present in other parts of EAB's range, and maybe some things that are worth trying to preserve. Nevertheless, we know from those other places what the outcome might be. And This picture in the lower left-hand corner is from Wisconsin. Picture in the middle is from Michigan, areas where emerald ash borer has gone through and essentially killed every mature tree in that forest. I'll talk about, and certainly others are well aware of the fact that there are lingering ash and ash that survive these areas of infestation. But the general outcome is the loss of mature ash from most areas, particularly black ash, but other species when it's moving through that landscape. And so knowing that that is the likely outcome without any intervention, there is this opportunity that we can actually work with some of the healthy ash we have. My son unfortunately chose this one to hug, not knowing its fate has already been sealed with that paint on it, but we can preserve other ash besides that one, potentially on the landscape, and really maintain some of those values and functions that have already been lost from a lot of areas where EAB has been moving through. So one thing I really need to confess to is that from my perspective, I've been involved with ash management in the context of EAB for, I guess, 15 years now. And initially, and really until recently, I often viewed things like insecticides and kind of individual tree protection as very much an urban, residential, kind of individual tree care approach. Those situations were not appropriate for a rural forest. We really shouldn't think about that, just not feasible. The economics aren't there, et cetera. But what we've gained from all of the work that's happened with emerald ash borer, both from the perspective of chemical controls, work done with biocontrols, and I think just a broader awareness of the value of ash species, both culturally and ecologically, is that there are tools that exist that have proven effective, and there are many good reasons for why we should actually be thinking about preservation. And so what I'm going to do today is basically reveal a bit of a change of heart in some cases, that if there are some opportunities that we can try to actually apply some of these strategies to rural forests, how might we do that, and how might we think about preservation? And so many others have thought about this before. I'm not the first person to think it through. And if we reflect on even one of the other webinars that Kate mentioned, the Hemiphilia deligid, that's a prime example of a species that, there certainly have been individual protection efforts at the tree level, but more discussions now about can we actually maintain that iconic species in different parts of the landscape, and so trying to do that. And so as much as I've tried to stay away from preservation, I've definitely had a hard time avoiding it as we move forward with ash. And as a simple example of that, I was actually down at my son's hockey game in Montpelier this past weekend. Here he is, of course, honoring the great Patrice Bergeron as number 37. And I was looking across the face-off circle, and there was even a sign telling me, I should be thinking about tree preservation, and TreeWorks can thank me for this free advertising. But what this speaks to is TreeWorks, as many are familiar with, or again, deal with urban residential settings. And what we're talking about here is how do we think about some of these ideas of tree preservation that have really been limited to these contexts to kind of the broad landscapes that we have ash in here in New England and elsewhere. So what I'm going to do is go through kind of some of the main goals with preservation, why we would even consider this, what would motivate someone to do this, and what's our justification, and then get into kind of the details of what we know at this point through all the great research that forest health protection folks and entomologists and others have been doing around ways in which we actually can protect trees and what that might look like if we actually integrate it into kind of our large rural forested landscapes. All right, so the primary goal, and I always will say the greatest impact that emerald ash borer will have once it's worked its way through the region is the cultural impact. And all of us hopefully are well aware of just the cultural significance of black ash in particular to Indigenous people throughout the range of that species, both from the perspective of cultural traditions and creation stories with the Wabanaki people, as well as cultural lifeways through the forming baskets from splints. The Ojibwe word for ash actually then gets linked to the Ojibwe word for snowshoe, and so there are many things that are connected to the ash and certainly deeply ingrained in the tradition of Indigenous peoples throughout its range. And so when we think about preserving ash and finding ways to keep ash in the landscape, one of our primary motivations very well could be that we're trying to preserve the cultural values that are provided by that species, both the value of having mature trees for reflection and inspiration out in the landscape, but more importantly, having those trees to also supply sources of material for making baskets and other culturally derived products. And so when we think about preservation and maintaining the species, oftentimes the conversations around culture go to, well, we want to maintain shade in urban settings, and we want to reduce people's utility bills by keeping a large ash tree healthy in that landscape. And those are certainly key cultural values. But deeper than that are the cultural values that ash plays within the tribes throughout the region. So thinking about ways and why we might try to preserve ash for those reasons. a lot of what we've discussed more from kind of a Western science perspective is that each tree species, hemlock being a great example, exerts a very unique impact on its local environment. And so what we're really seeing is kind of the functions that that tree species provides that might be distinctive relative to any other tree species. And so in the context of ash, one of the reasons why we might put a lot of effort into maintaining that as part of the northern forest is that we want to maintain those unique key functions that the different ash species found in our forest provide. And so one prime example, if we think of ash-dominated wetlands, so the functions that ash plays both in regulating water table dynamics, as well as the functions that ash plays in terms of, during flooding events and ameliorating those extremes. And then when we look at ash litter, I've talked about this before, but all species of ash have a very high quality litter. And so when that litter falls into an aquatic ecosystem, it has a tremendous impact on the productivity of those food webs. So tadpole productivity, caddisfly productivity are often much higher in food webs that are dominated by ash litter relative to others. And so thinking about those functions, and if we were to lose ash from those ecosystems, will those be sustained? In the uplands, again, we all recognize this, those of us that are working in northern hardwood ecosystems with a lot of ash in them, it's always the last tree to leaf out. It's always the first tree to lose its leaves. And what that does is that anything growing around that or beneath that actually has a longer growing season effectively because there's more sunlight reaching the ground. So there's some unique microclimates as well as unique soil characteristics that are found only around white ash. And the final piece, and I'll certainly talk about this quite a bit, is that white ash in particular in our uplands really is generally one of the largest diameter trees we have in our forests. The white pine being kind of the only other species that is more commonly the big tree out there in the landscape. And so as we think about large tree habitat, think about just how important large trees are for carbon storage, maintaining that function is pretty critical. And so, there might be situations where we're trying to preserve and maintain those big trees as long as we can, just given we know how long it takes to get to trees those size again. So the last reason for preservation is what we call genetic preservation. And so thinking about really trying to maintain the reproductive potential of that species on a site, so trying to protect seed-bearing trees, such that we might be capturing some of the genetic variation within the species and hopefully some resistance. We've done a lot of work when folks are looking at active breeding programs for ash to try to identify individuals that show some elements of resistance, and so collecting seed from those individuals, trying to breed those individuals with other ash, and finding ways to just increase the amount of ash in the landscape that might provide hopefully some sort of solution going forward in producing individuals that are genetically resistant. And so those three goals, functional, cultural, and genetic preservation goals, are all different reasons why we might think about actually investing in trying to keep ash in the landscape and maintaining some of those cultural, functional, and genetic values. So what I'm going to do is go through the different preservation approaches that currently exist and really talk about them through the lens of a forested setting. And so, again, recognizing that a lot of the discussion around keeping ash healthy and maintaining ash in light of an emerald ash borer outbreak has been focused primarily on urban settings where you're treating individual trees or groves of trees. But again, I've really been able to benefit from the knowledge of many folks like Nate Siegert, certainly Bill Davidson and Kyle Lombard from the state of New Hampshire have all been really helpful in helping puzzle through, how might we do this if we were actually to try to protect trees over large landscapes and maintain ash as part of the future of our forests beyond just some individuals sprouting off of trees that are getting killed by emerald ash borer. So I'm going to first start off in the area where I feel most comfortable, which is talking about silviculture and some of the things I've discussed before in terms of using management of ash in a way that actually keeps future options on the site, and then get in more specifics about some of what we know as it relates to chemical treatments, biocontrols, as well as cultural adaptation practices as ways to preserve those functions and find options for keeping ash out in the landscape. So from the silvicultural perspective, and many of you are aware of this, and I certainly am a skipping record on this, white ash continues to be, despite markets doing what they're doing, still is a very strong species from a market's perspective relative to others, and that there's still a reason that folks would want to go out and cut white ash. And emerald ash borer in many cases provides even that much more reason. And just to point that out, there's been some recent survey work in northern New England from the Harvard Forest that's shown that, when faced with the threat of mortality by an invasive insect, 62% of family forest owners are motivated to harvest. And so we have this motivation, both economic as well as just the fear of losing that species, that's going to continue to have us look at ash with the paint gun ready, and that this is a species that's threatened. If I want to capitalize on the economics that still exist for that species, now is the time. And I'm not going to fault anyone, and really, not against people doing that in terms of thinking about trying to capture those economics. But what I am against is folks doing it without thinking about the long-term options in that site, and so doing harvest and not doing silviculture. And so the goal really, if we're harvesting those trees in response to the EAB threat, and we want to do that with preservation in mind, kind of preserving those options for that species on the site, there are two key elements of that harvest. One, that we're doing it in a way that recruits new generations of ash, so we're actually getting ash regeneration on the site with that harvest. And secondarily, we're also leaving some mature trees on that site to linger, potentially, in response to emerald ash borer, or in some cases, maybe even be the trees you decide to protect with other types of treatments. And so thinking through both the future of ash as well as what's currently on site and how do you work with that through these harvests. So the regeneration piece, again, talked a lot about this in other webinars and presentations, but we know that if you just selectively pull ash out of a stand with purely economic means and don't think much about kind of regeneration environment, you very likely are not going to create enough light for ash to recruit. Same goes for letting emerald ash borer work through a stand and selectively kill ash, nothing else. It's just not going to provide enough light on average for what white ash needs to recruit from a seedling into ultimately a canopy tree. And so when we talk about the silviculture of white ash, we're getting into regeneration methods where kind of large openings are a key feature of that. So whether it be group patch selection, again, looking at a third, if not larger openings, seed tree, both regular and regular shelterwood, all of these methods are providing that light environment necessary for white ash recruitment. And so if you are thinking about harvesting ash, these silvicultural systems should be kind of what you're reflecting on in terms of what might make the most sense. So as an example, the seed tree harvest here in the lower portion down in the Peru town forest, you can see the leaf trees of ash being left behind, but certainly a lot of ash being removed, kind of creating that light environment. Likewise, low density shelterwood here for white ash recruitment, and a large group selection opening, again, anchored on a white ash, again, trying to get a mix of species, but also keeping white ash as part of that. What's key about all of these is that they are not only providing the regeneration environment necessary for white ash, but they're also leaving behind white ash. And so when we're thinking through trying to both get future generations of white ash in the landscape, as well as provide that long-term function of large trees, leaving those big trees out there, or some big trees out there to be tested by EAB, as well as, again, possibly to be protected, and we'll talk about that a bit more, it needs to be part and parcel with those harvests. On the big tree part, so if I'm doing silviculture and you hear me on your shoulder saying you need to leave some mature ash behind, really trying to prioritize what will most be lost when EAB comes through, which are those large diameter trees. And in some cases, you don't want to remove, you want to remove some of those large trees just given markets, but oftentimes some of those really big ash are not very marketable. And so using those as opportunities to really leave behind those large diameter trees that are going to provide critical functions, both from a carbon and habitat standpoint. Likewise, if you can identify the sex, certainly prioritizing female trees. This picture here on the left is an example of that. Some work that Rick Morrill is doing up on TNC lands in Greenboro, Vermont. You can see he's marked this tree with an F. I tend to use a little bit brighter red when I assign Fs. Actually, UVM forestry students never fail, but this tree kind of earned the F. This is a well-deserved F. So this is a female ash tree being left behind, and recognizing the value of that tree in the site and not harvesting it, and maintaining that as a seed source on the site. So many are already well aware of this. It certainly has changed some of our discussion around me even suggesting leaving ash behind in the site, but resistance does exist. And there's been some great work out of Michigan with Deb McCullough's group, where they've been following areas with emerald ash borer infestation for over 15 years now, and resurveying those areas. And in some cases, what they're finding are pretty high levels of survival of white ash, particularly those with healthy crowns, high vigor trees that already are in pretty good condition from a vigor standpoint. So this figure here, many are already familiar with it, but what we're looking at here is just a proportion of trees alive relative to where emerald ash borer first was originated. And you can see that many of these areas have very high levels of survival, despite EAB having been present for over a decade. So there is some evidence for resistance. At the same time, there is some evidence for stands where all the trees die. And so you can't assume that every tree is going to survive out there. But we do know that, no tree is immune to a chainsaw. And so if you're not leaving some of these trees behind, we really are losing an opportunity to both understand where there might be some future resistance, as well as opportunities for ash on the site. And so really trying to build those together. The last comment on silviculture is that by doing this approach, where you're both recruiting new cohorts of ash, at the same time maintaining some mature ash on the site, in many cases, you're actually setting the stage for some of these protection measures to be a bit more effective. And what I mean by that is that some of these techniques, like biocontrols, and I'll talk a bit more about it, some of the organisms are only very effective on small diameter ash. Others work fairly well on larger diameter trees. And so having a stand that has both small diameter ash present via your efforts regenerating it, as well as some larger diameter trees that have been left behind, provide kind of multiple pathways for biocontrol. And likewise, we'll be talking about chemical treatments in a moment, but those aren't cheap. You can't do them to every single tree in a stand. And so by retaining some individuals that you want to kind of leave out there for structure, it might allow you to focus your insecticide efforts onto those trees if that's something you ultimately choose. And so I'm going to get into now talking about those treatments that actually are going to come at a cost. The silvicultural strategies, obviously there's the opportunity for these to pay for themselves and then some. And so what we're going to get into is really some territory that is not going to be for every landowner, it might just be for a few, but how we might actually think through if a landowner or an agency has the resources available, what might be the most effective strategy to actually start deploying some of these protection measures in a way that ensures that we have ash across the landscape. So the most commonly thought of and most effective way for limiting and eliminating, in some cases, the impacts of emerald ash borer from a tree and from an area is the use of insecticides. And there's some tremendous outreach documents that have been maintained and updated over the years. Again, Deb McCullough, Dan Harams, and others have really been doing an amazing job just keeping us up to date on what the current technology is with insecticides for protecting ash. And there are many different approaches. But when we're talking about applying insecticides in a forested settings, there are two key things that, at least from my perspective, have to happen. One, it has to be cost effective, which means it has to last for a while. And two, it has to have minimal kind of non-target impacts. And so the one insecticide and kind of the one approach that really kind of fits that bill is emamectin benzoate, or triage, which, as many of you are familiar with, is injected into the stem of ash. And what's really powerful relative to other approaches is that this lasts for 3 years, and not just in a 10-inch tree, but there's evidence that shows even 60-inch trees are protected with this insecticide. So being a stem injection relative to soil applications, there's no documented impact on aquatics, and likewise, ash is a wind pollinated tree, so we don't have pollinators visiting the flowers. And so a lot of the pollinator impacts from other insecticides are when they're soil drenched or other approach, they get into other flowering plants. And so in this case, this is going right into the ash, and so there's minimal and no documented pollinator impacts to date of emamectin benzoate. The cost per tree, this is kind of an average, but it can be much lower depending on who you're working with and kind of the rate they're charging. But generally, the going rate is about $5 to $10 per inch. And again, as I mentioned, most folks view this as a 3-year treatment, and some even a 4-year treatment, depending on who you talk to. And so certainly something that can be quite effective. There are organic alternatives, those that aren't excited about emamectin benzoate. There is an alternative, as triazine, azadirachtin is the compound in that, which is a derivative from neem tree oil. And this also can be effective, but there is work that has shown that when we have high densities of emerald ash borer, it needs annual applications. And so as opposed to emamectin benzoate, where you apply it and then you don't have to worry about it for several years, with triazine, if you are in an area with high AAV densities, it really seems to be an annual application. So the costs go up quite a bit, as well as the effectiveness is a little bit less relative to emamectin benzoate. So if you're even considering doing this, there's some key things to factor in. One being timing, one being what trees, and then the other being kind of how many. And so I'm going to go through just some of the basics of, if you're even considering this, when you would do it, how, and what might make sense at a stand scale. And so the timing piece, with any use of insecticides, you want to minimize how much is going in the environment. So you want to be using it when it actually makes sense to use it. And you also want to minimize costs. So you want to make sure, again, you're using it when it makes sense to use it, and when you actually are having impact on the organism you're trying to minimize the impacts of. And so generally the rule of thumb as it relates to applying these to protect trees is that you want to be either in an infestation zone or in the area that's a likely potential expansion area. So using the state of Vermont as an example, these red blobs, and many of you are familiar with these maps for all of our states, these are the areas with confirmed EAB infestations, and then this is the ring of areas that are likely have infestation as well, or are soon to have infestation. And so the rule of thumb historically has been 10 to 15 to even 20 miles outside of the active infestation, but more recent guidance is even saying within 15 to 30 miles, because we just don't know where EAB is in the landscape oftentimes until it's a bit too late. And so by being a little bit more liberal in terms of where we're treating trees outside of the known infestation zone, we might be catching a bit more than we would have if we had a more conservative estimate. And so that's generally our timing in terms of, depending on where you are, when it would make sense to start doing this. And then in terms of timing as it relates to when do you actually apply these, again, I recognize many logging on or do this for their own business, but generally we're trying to maximize impact both on the larvae, so the eggs are hatching kind of in late spring, so that's when the larvae are starting to come out. Then we also want to be maximizing impact on the adults feeding on leaves, and so these late spring applications really get that insecticide going through the tree into the foliage when those EAB are emerging and eating on those leaves. And I just take such pleasure seeing this little insect here now, and that's the last meal it'll ever have there. So that's our goal. So just to kind of look at this graphically with cost over time, there's some great tools out there. Purdue has this EAB cost calculator with a major caveat that it was developed both with costs that you might pay in a more urban setting as well as the logistics of an urban setting. But what I've done here is just put in the cost for treating 12 saw timber size trees over time. And what you see is that kind of every 3 years you're incurring this cost, and then over time that cost actually is spaced out with the assumption that EAB populations ultimately crash in an area, and so the need for additional maintenance and investment in these treatments goes down. But nevertheless, it's not a trivial amount of money that's being invested into a forest stand. So if you're going to do this, and you don't want to be wasting money and spending lots of money on things that aren't going to have success, one of the key considerations is which trees do you treat? And again, I want to acknowledge, again, pictured here, Kyle Lombard, as well as Bill Davidson, State of New Hampshire, as well as Nate Siegert for being very helpful in puzzling through some of this with the work they've been doing. But in general, we're talking about trees that actually are worth saving with insecticides. So trees that actually can not only have the vigor to deal with you putting holes in it and injecting insecticides, but also that can recover from that EAB impact, or at least kind of work through that as it's being treated. And so in general, trees with greater than 50% crown dieback, are not really able to recover effectively with these treatments. Historically, they would say 30%, but more and more folks are saying 50% is kind of that key threshold. So if your trees already have crown dieback beyond that, unfortunately, you're kind of out of the range of this making sense. If you do have those trees, then need to think through, well, what are my goals of preservation? Like, why am I investing in preserving trees out there? And so if your main goal is cultural, you might consider really protecting those trees that would be suitable for future basket material. So we're not talking every black ash. Some of the work that Mike Benedict did in the Lake States and Larry Diamond worked on here in New England shows that 1 to 20% of all black ash in any given population are even suitable for basket material. So those might be the trees you prioritize, with a key caveat that, at least my interactions with basket makers, some aren't too excited about then harvesting that tree and using splints from a tree that's been soaked with insecticides for years. And so those might not be the trees you're protecting, but or thinking through kind of a balance of basket worthy and other black ash. From the functional standpoint, I really will argue that this approach using chemicals is the only one that's effective at preserving big trees. And so if we really care about maintaining big ash in the forest, this is our tool. And so I'll talk a bit more about how we might prioritize that, but if I'm really trying to maintain that large tree function, then large size classes are what I'm going after. And then from the genetic standpoint, if I really want to maintain the genetic capacity, really prioritizing sexually mature and ideally females, and some of the work that, again, UNH Woodlands with US Forest Service have been protecting roughly 75% of the individuals as female where they can find them, as well as in general, if you see trees that are showing some initial signs of resistance, those would be the ones that you really want to prioritize for protecting and keeping on the site. So this is where the real challenges come in. How many trees do you actually treat, right? So it's a bit different than somebody has 2 ash trees in their yard. Right now we're talking about forests and regions and landscapes. And so it really, again, depends a bit on your goals, but also what type of ecosystem you're in. And so I'll start with what is not the most common, but a unique situation where we have these ash-dominated lowlands. And so here we might have a scenario where ash makes up a large proportion of the overstory trees, and some of the concern might be on certain sites, losing that ash, emerald ash borer, could cause that forest to shift to something other than forest. So it might swamp out and become kind of marsh or kind of tag alder, or you might have a release of things like reed canary grass that are in the understory. And so if your goal is to try to keep those as functioning black ash or green ash dominated wetlands, what we found, at least in some of the research looking at different harvest levels in these forests, is that once you get above 60% of the dominant and codominant trees removed, you start seeing some pretty pronounced bounces in the water table that do shift it towards growing conditions that are not favorable for most tree species, including ash species. And so if you really have the will and the way, ideally for protecting the function of these areas, you're likely protecting 40% of the dominant and codominant trees, which I recognize that the price tag on that could be quite high. From a cultural lens, if you lose ash and it causes that forest to shift to something that can't support that species over time, you would have a similar approach. Can we figure out a way to keep this ash dominated such that we can over time sustain production of basket-worthy trees on that site? And likewise with genetics, same idea. If we need to keep that site, as a functioning ash forest, then it might be a pretty high level of protection in those areas. On the flip side, where most of us encounter ash and even think about cutting it, are in our upland forests. And again, I've been viewing this from the Vermont lens, and many other forests that are logging in here. Then our northern hardwood ecosystems, often ash is not the dominant tree. It might be 20%, sometimes on certain sites 40%, and even extremes above that. But generally, it's a pretty low, 10 to 20 to 30%, depending on the fertility of the site. And so within these northern hardwood systems, it really depends on what your objectives are for the species. It's a very important part of our northern hardwood forest, and so it'd be great to keep it as part of that. But it just depends on what our objective is with protection. And so if your goal really is functional, you're trying to maintain the unique function that white ash plays in our northern hardwood forest, I would argue that its most unique function, besides its unique phenology and leaf litter traits, is that it's the big tree in many of our forests. And so the drawback to that from a chemical treatment standpoint is that those big trees cost a lot of money. And so I often view this type of protection really being for a single site where you really want to invest a lot in maintaining that large tree function. And so trying to distribute potentially across the site, so this diagram here, I'm showing it, where you're across that site, you're trying to protect ash in a fairly distributed fashion if ash exists like that across the site, such that you're maintaining that big tree function at the property level, recognizing that you're kind of sinking a lot of your resources into that spot and might not have a lot of resources to go elsewhere. The other approach, and one again that the state of New Hampshire, I have a photo here, Bill Davidson with Carol Lombard's work with their treating trees, in different places throughout New Hampshire. In that case, the goal really is to maintain that genetic potential and seed production on site. And so instead of choosing the biggest trees per se, you're choosing a range of trees that are a bit more cost effective for insecticide treatment, still dominant, codominant, healthy trees, but you're really selecting those in a localized area within the stand. So this picture here is just showing a bunch of stands across the region where instead of treating the entire stand, we have these localized pockets of ash being treated. And the reason why there's a lot of good thinking behind this as it relates to that possibly being an effective way to protect groups of ash with a lower amount of insecticide. So there's been some really recent work that's quite promising as it relates to the value of a tree that's not treated with insecticide being next to a tree that is treated by insecticide, and there being some co-benefit of that treatment. And what folks are finding is that when trees that aren't treated with insecticides, so an ash tree next to a treated ash tree, it has a crown that's either basically commingling with that tree or is just in very close proximity, it seems to receive the similar benefits of that control. Again, thinking about those adult EAB actually eating those leaves and basically keeping the populations down. So this graph on the right-hand corner is actually from some results from work looking at this, where they have canopy condition from healthy to unhealthy. And this neighboring index really represents it's kind of an index of of how many ash trees were close to a given untreated, how many treated ash trees were close to a given untreated ash tree. So the higher the number, the more trees were around that individual that had received insecticides. And what they find is that those untreated ash that are adjacent to many or even a single large diameter treated ash seem to also be receiving some benefit from that treatment. And so by doing protection in this way with chemicals, you're kind of localizing your impact and possibly benefiting more than just those trees that you're treating. So beyond chemical, the other main approach we think about are biological approaches. And so as with the chemical, it doesn't make sense to be doing biological releases anywhere where emerald ash borer is not present. Largely, you're releasing a lot of biocontrols that are going to be very hungry and not have much to eat upon. So thankfully through APHIS and all of our state partners and federal partners throughout the region, there's been a ton of work looking at biocontrol releases in the region, and you can see where those biocontrol releases have occurred. They nicely coincide with where we have documented infestations of emerald ash borer. Again, the reason being we need to make sure there actually are populations of EAB to sustain these organisms. And from that work and work that's happened as well in the lake states, there's a lot of promise with biocontrol. And I would argue that biocontrol is one of the key elements to sustaining ash over time in the landscape, just given how effective some of these have shown in sustaining and reducing EAB larvae during outbreaks. So the three common parasitoids that we now are viewing as being really good options for northern forests are Tetrasticus, which is a larval parasitoid and really the most widely released, Spatheus, which is another larval parasitoid, and this species is actually a newer one. The other species was not very effective, but this one shows a lot of promise, and I'll talk a bit about that in a moment. Nubius, which is an egg parasitoid of EAB, which of the three has not really shown the highest level of protection in terms of the level of egg parasitism, but nevertheless is a great option in conjunction with others in terms of trying to have multiple pathways that are keeping emerald ash borer densities low on a given site. So when we think about these parasitoids and their use as a preservation strategy, really the condition of the forest and what we have out there matters quite a bit, in that these aren't foolproof in protecting all sizes of ash. And in particular, there's very little evidence of these parasitoids being able to protect trees with a diameter bigger than 15 inches. So if we think about that functional role of large diameter ash, these parasitoids to date really haven't been documented, even though some suggest they might be able to protect up to 20 inches. There hasn't been a trial so far that's been looking at very large trees that's shown high effectiveness of these parasitoids, at least none that have been published that I've come across. And the real issue is that the ability for some of these parasitoids, and particularly to Tetrasticus, who really, is quite effective at keeping small diameter trees in check, but when it comes to kind of larger diameter trees, the ovipositor it uses to actually get into the larvae is just too short to get into them. It really can't protect those individuals. And so we often view this as a tool that's very effective on those smaller diameter ash. There is, again, a lot of recent work that shows promise with Spatheus that it actually can reduce larvae on larger trees, but that study, which was done in Connecticut and New York and Massachusetts, as well as some sites in Michigan, the largest diameter trees they were looking at were 15 inches. So we still are uncertain as to how effective those will be on all ash trees. But nevertheless, this really speaks to the fact that if you're doing silviculture with ash in mind and recruiting new cohorts of ash, retaining some larger ash, that you're creating kind of this condition that those parasitoids actually can respond to in an effective way and provide a lot of protection, particularly on those smaller trees. And those wondering, just for scale, here's a picture of those two next to each other. So you can see why this one here can't get into bigger trees. But the recent work has shown there's some pretty interesting dynamics that go on between these two parasitoids. And in particular, when they're released on the same sites, basically Tetrasticus goes into those smaller trees. So basically is going after kind of those smaller size classes and really focusing in on them. Whereas Spatheus is going after kind of those larger size classes. And so on the same site, they're really serving different functions, and argues for these releases, which many of our forest health folks have been doing, of multiple organisms at a site to really provide that protection. So the last adaptation approach I'll talk about beyond chemical and silvicultural and biocontrol are thinking about cultural adaptation approaches. And so doing things that provide these future options, both for the species biologically, but also on the cultural use of that species. And so really thinking about this in the name of future generations of ash. And so one of the things that's really become a priority as we think through kind of future options for ash and preserving those future options is that, trying to collect seed from ash as a way to sustain the species over time, and both from an ecological standpoint, but also from a cultural standpoint. And to that end, there's a lot of work and a lot of credit should go to Les Benedict and Richard David and others with the St. Regis Mohawk and other tribes who long before emerald ash borer were already doing a lot of active seed collection of black ash with the idea that this is a key way to sustain black ash on their landscape and other landscapes for future basket material. So a lot can be learned from talking to tribal partners about experiences with ash seed collection. And certainly as we think through kind of options for what trees we collect from, some of that should be geared towards trees that might have desirable traits as it relates to basket making, although in many cases that's often more of an environmental versus a heritable trait, as well as individuals that might show the potential to linger. And so if you really get excited about collecting ash seed, timing is everything. Making sure you're collecting it when it's mature and still on the tree, so September through October for all of our ash species here in the Northeast. If you're not used to collecting seed, which is really the case for many of us because we rely so much on natural reproduction, so few of us are collecting seed and then sending it to a nursery to be grown out. So if you're new to this deal, the key part is source control, so documenting where you got that seed, kind of the conditions of the site. That way, over time, as we think through restoration as well as preservation, we know where a seed came from and what individual has grown from that seed make the most sense for a given area. Then finally, we're very fortunate, again, I mentioned already the work that St. Regis Mohawk have been doing for decades, but there's also more recent efforts with MAMA. The Wabanaki people are also doing seed collections in Maine, as well as national seed collection efforts that you can coordinate with and certainly make sure you're not duplicating their efforts, as well as get some guidance on how do you process and store seed. In particular, the USDA Forest Service National Seed Lab is really good about both giving advice as well as certainly providing some information as to whether or not it makes sense to collect seed from a given population. The other aspect of thinking about cultural adaptation and providing future options for black ash in particular is not just future options for that species biologically on the site, but also the potential for future black ash flint material. And again, I don't want to get completely gloom and doom here, but black ash, of the 3 ash species, there really has been very, very limited evidence of resistance. It's the most vulnerable. And so there is a likelihood in some portions of its range here in the Northeast that it will be wiped out as a mature tree in the forest. And so as we think through that, and again, think of the cultural implications of losing those mature basket quality trees, one potential strategy for preserving that is to actually harvest some of those trees now, pound splints out of those trees, and actually kind of store those splints for future generations to use. And there has been a lot of work that's shown these splints can be pounded out and rehydrated. And so as opposed to sinking logs, which have kind of a limited time frame in terms of how long you can store logs without decay getting into the wood, with splints, there's a lot more opportunity there to do that. And the real challenge and hurdle of this strategy is that if you have black ash on your land, you're very likely on land that was ancestral lands for one of our tribes in the region, but in many cases, those tribes no longer have access to those areas. And so if you're a landowner or working with landowners who have black ash on their land, one key thing and key element to this preservation is to think through, am I willing to both document what those areas are and restore cultural access to these areas with Indigenous tribes through land use agreements. And so allowing those that value that species so much more than any of us could appreciate access to that material as an opportunity to preserve it for future use. So there are some precedents both locally. Vermont Land Trust, Vermont Family Forests have example land use agreements for tribal cultural access and material access, as well as some national examples that are worth thinking about as we try to preserve this species and its lifeway and tradition going forward. So one size doesn't fit all, and this is a challenge that needs to be met from many different directions. And so I've always lead from a silvicultural lens and will continue to lead from a silvicultural lens. And as I mentioned at the beginning of this presentation, this is a bit different way of me thinking about how we manage large areas of forest, but there really is a unique opportunity to start trying things and some tremendous people to learn from and how that might work. And so given the costs and given kind of the differential effectiveness of some of these treatments, it makes sense to apply things like insecticides and biocontrols, and they often are on similar sites if EAB is already present. And part of that can actually enhance the effectiveness of each treatment. And so localizing those systemic insecticides on some large diameter trees, in some cases might actually enhance the, how effective some of these natural enemies like woodpeckers and parasitoids are on untreated trees. And what I mean by that is that woodpeckers and parasitoids won't eat dead EAB larvae, right? So those trees being treated with insecticides are not going to be visited by woodpeckers or parasitoids, and so they're going to hone in on those untreated trees and kind of maximize and enhance that benefit. And of course, doing that within the conjunction of some good silviculture provides that range of structures and age classes out there for that. The other thing that's critical, and it's never exciting to say we need more surveys and more purple traps and other things across the landscape, but more now than ever, as we think through using some of these treatments, timing is everything. And so you don't want to be using insecticides before EABs in that landscape. Likewise with biocontrols, silviculturally, we might have some time markets-wise as well as just opportunity-wise to do things ahead of that wave. And so really paying attention to where EAB is in the landscape, and importantly, you, someone that spends time in the woods, also being a detector for EAB. We all have a good sense now for what that looks like. When it's first getting into trees, looking for blonding in the crown. And if you see that, and suspect it, report it. And I will plug here for noninvasives.org, and a plug as well for Josh Hallman and all the others in the state of Vermont that get to respond to these requests. But basically, citizen monitoring is equally important as having these monitoring efforts happening at the state level. And they're really critical to understand, what techniques do we have at our disposal, and does it make sense to be starting to preserve with chemicals now, or wait for 5 years, depending on where you are in the state. And then finally, I think the biggest lesson from what I've learned, at least being involved with emerald ash borer, and again, I feel it's been a privilege to get to connect with so many people with, sadly, a motivation of the loss of a species or multiple species, but nevertheless, a pretty powerful group has been pulled together, throughout the Northeast, certainly the Lake States and other places where ash is threatened. And what's powerful about that group is it represents not just foresters, not just forest health protection specialists, not just tribal partners, but really a whole range of backgrounds and perspectives on this challenge that really, I think, allow us to hopefully start pushing the envelope a bit about how we're thinking about keeping the species in the landscape and protecting many of those values. And I really should acknowledge both the efforts of the Forest Stewards Guild, Vermont Land Trust, Vermont FPR, University of Maine, and others that have really been catalysts to bringing folks together and thinking through these issues and trying to find ways to move forward. And I was the poor soul that was asked to talk about preserving ash in the landscape, but hopefully today is just to start the ball rolling for those that can think about this a bit more intelligently and logistically at how do we do this at scale. And I would already argue there's a lot we can learn from what the state of New Hampshire is doing currently with their efforts, but trying to find ways to think this through and prioritize, what sites, how do we do it, how do we keep those costs down and maximize positive impact. And so with that said, I will end with where I started a long time ago with emerald ash borer when it first began, is that I'd said it wasn't feasible for any stand to do some of these preservation strategies, just given I thought the scale and at the time, even the effectiveness of some of these treatments, just there wasn't enough proof yet that it really could work quite well. But I would argue the time is now. We really have this unique window where there's a tremendous body of knowledge about how effective these tools can be to preserve ash, and we still have ash to preserve that's mature. We still have ecosystems to preserve that don't have heavy EAB impact. And so if you do have ownerships or opportunities or grants or funding or other things where you can actually get involved or apply some of those tools to preserve some ash, and I'm not saying entire landscapes and stands, but preserve some of those ash, the time is right to start trying that. And importantly, the time is right also for us to kind of think a little bit outside of the box in terms of sharing knowledge, in terms of how people are approaching this and working through that. And again, I benefited a lot from some recent emails and with Bill Davidson and Carol Lombard and a lot of conversations with all the authors that were on the beginning of this talk that, puzzling through this and thinking about how do we actually protect species is really critical. And sadly, this might not be the last time we're talking about how do we do this for another insect and disease. And so building that community is going to be so critical for maintaining those functions over time. And so with that, I'll end by acknowledging the community. That certainly has been helpful today and as well as in other conversations and thinking about this as well as many others. And I'm happy to take questions folks might have before you run out and buy your own arbor jet system to start treating trees.
Excellent. Thank you so much, Tony. And you've given us a lot to think about here. And we really appreciate your thoughtful approach to this question and to this topic. So we do have a number of questions that have come in, and just picking up on the last point that you had mentioned, one of the first questions we have is, how do folks find somebody to, is it legal for landowners to do the treatment on their own property? And if not, sort of what are your recommendations for folks who are looking for help with doing the chemical treatment?
Yeah, so for landowners and anyone, you need to have a certified, you have to have a pesticide license to be applying these treatments. And so most arborists, tree care individuals, as well as there are some consultants that also have those licenses now. And so working with those individuals that, or if you're interested in doing yourself, then getting licensed through those programs. But you want to make sure the person doing it, certainly is aware of dosage, and again, the key element of not too little and not too much of the chemical, and minimizing impact. And also, those arbor jets and those injection systems, it's not a trivial cost. The kind of most basic ones are a few $100s, and some of the more advanced ones can run up to a few $1,000s. And so someone that's invested in that equipment knows how to use it effectively. So I would talk to a licensed applicator, which the majority of our tree care individuals have those licenses, and like I said, some foresters as well have that license now.
Excellent, thank you, Tony. And also I'll put a link in the chat, but the Urban and Community Forestry Program, if you go to our website, we do have a list of permitted applicators on our website, and that's vtcommunityforestry.org. Now, those are mostly arborists, so there is that sort of urban forestry lens to the list, but that's a place for folks to be able to get started as well. So again, a number of questions here, and I'm afraid folks probably won't be able to get to all of them, so I'll try to hit the big ones. One of the questions here, Tony, that has come in is around the Asian species of ash, and wondering about, has there been any discussion or thoughts about looking towards, sort of planting Asian species, within our forests, and why might that not be a appropriate response and approach?
So I'm guilty as charged on that. So we've done some working with Manchurian ash, which some may have intersected with in urban. It has been planted in the Northeast and in urban settings, and is native to the range of EAB and resistant to EAB in China. And so we've actually included planting of Manchurian ash in some experiments, primarily in the lake states. And the inclusion of Manchurian ash in that case was motivated by Mike Benedict, Les Benedict's brother, who works for the Bureau of Indian Affairs, had done some work showing you could pound splints out of Manchurian ash, and you can. It's a bit more work, or a lot more work than black ash. The main limitation is Manchurian ash. The cold hardiness, at least from what we've observed, is it really is not cold hardy to the environment. And so the fact that it's a non-native species being the first concern, the potential for that to become invasive, although again, at this point, there hasn't been evidence of it escaping from urban plantings. But beyond that, it doesn't seem to show the cold hardiness that black ash shows. And so a lot of the breeding efforts that Jennifer Cook and others are doing, trying to kind of breed resistance to emerald ash borer and black ash in particular, they're trying to cross that with Manchurian ash. And so there's a lot of work looking at those crosses. But in terms of planting out in the landscape, I'm not aware of any upland work that's trying to plant it in northern hardwood systems, but we have done some work planting it in lowlands, and it survives, but it just kind of dies back to the root collar from frost injury. So it's just not, at least the varieties that we were able to get seed source from wasn't cold hardy, but it could be a potential basket material. And there are other species like white oak and basswood and northern white cedar, Phragmites. There's other species that can be replacement material for black ash, but obviously that would be the prime and the ultimate, both for cultural traditions as well as for those lifeways.
Excellent, thank you. Another question, going back to sort of the chemical and biological controls. Somebody's wondering, would those be mutually exclusive? So in other words, do chemical treatments also negatively affect parasitoids through direct toxicity, the word's not coming out right, rather than suppressing the EAB populations?
Try saying tetrasticus a few times. Yeah, so that's an excellent question. And so what I was mentioning there was both native parasitoids. So again, we can't we always get worried when we see woodpecker activity on trees. What they're doing, they're trying to be a biocontrol, and they are a biocontrol. So woodpeckers, as well as so there are some native insects that will parasitize EAB, not at high levels, and then the ones that we're releasing, these wasps and flies, all of them want living larvae. So any tree being treated with insecticides, they're not going to be attracted to and trying to feed in. So they're actually very complementary. And the only challenge being that you need to have EAB present on the site. And so if you're doing insecticide treatments kind of in advance of infestation, you might hold back a while before you're trying to get those biocontrols established. And again, I tip my hat to the forest health protection units in all the states. They are releasing parasitoids with the hope being, and many have been, establishing populations in places where EAB is present. And so over time, the hope would be those parasitoids would naturally spread into the stand once EAB is there. But if you were in an area that you currently were treating with insecticides, EAB showed up in that stand, and biocontrols were released, you would not have an impact on them, and you actually would maximize their effectiveness, because they're gonna zoom in on those trees that don't have insecticide in them, and so they might provide kind of that beneficial protection that you're not getting on those trees. So no, they work really well together.
Excellent. A question from Alan wondering, do we have a map of where the parasitoids have been released? Do you have a sense of where they've been released?
So the APHIS map is, there's one through 2021. So the one I showed is kind of the most recent APHIS. And so that should be the up to date, but I also know, like I've stolen the ones from the state of New Hampshire in the past. You saw one from 2016 in that presentation. But I would argue that if you're in an area with infestations, and it'd be critical just to communicate with those that have access to those resources to see if you can get biocontrol releases happening in those places if they aren't already. But I'd reach out, like the state of Vermont. Josh is going to hate me for all these plugs for reaching out to him with things, but Josh Hallman or others that are really leading that effort would be good contacts if you're in Vermont. And then the APHIS website, they do have maps that can give you at least a general sense that where it's being released. And so if you see those red dots in the map, and it's you're in a county or an area that's not, you're not seeing that, it might be worth connecting with a local forest health person to find out what the activities are.
Great, and a few more kind of follow-up questions regarding kind of the impact and the risk maybe of the insecticides, using those, and the risks towards birds, woodpeckers, feeding on infected trees. Can you talk a little bit more about kind of the research around the risk of Emma, and I don't have it up in front of me, the insecticide that you had recommended, and our understanding of the risk to woodpeckers and other species?
Yeah, and again, we benefit so much from all that's been done, particularly at Michigan State. I mean, Deb McCullough's group has just been tremendous in just providing so many side-by-side trials and kind of long-term evaluations of effectiveness of every single insecticide in the market, including the work with the organic insecticide that I mentioned earlier, and the triazine. And so, what they found is, again, the real kind of non-point impacts, the situations that you don't want to be in, are where you have an insecticide that is not only getting into the tree you're trying to treat, but also is getting into other flowering plants, as well as getting into the soil, where it's going to have impact on microbial communities. And then also, just to point out, metachlorprid, the soil treatment that often can be used in urban settings, is not actually, there actually is a per acre limit on how much you can apply. So that's really, to me, a no-go in an urban setting, in a rural setting. And that per acre limit is because once you get above a certain level of application to the soil, there is risk of water contamination and so forth. So a lot of the impacts to pollinators that you read about really are from those soil applications, because again, it gets into the soil, it gets into a flowering plant, a pollinator uses that flowering plant and is impacted. So ash flowers, but it's wind pollinated, so it's not being visited by pollinators. And the systemic, so basically injecting that into the tree, you aren't allowing it to get in the soil. It's going right into where you want it to go, and it's quickly being moved through that tree. And so as it's moving through that tree, a reason why we want to do it while the larvae are hatching is that they're going to get killed. So it's going to kill the larvae that are in the tree as it's moving through that tree. And then as those trees are kind of moving that material into their leaves, it also kind of makes their leaves toxic to the emerald ash borer adults that are feeding on that. So woodpeckers are not going to be eating dead larvae. And so when people think about kind of impacts to woodpecker communities, they're not, the work that's been tracking it, they're not going after those trees that have insecticide treatments. And so the work that's been done to look at kind of non-point impacts has shown that there isn't an impact to woodpeckers. In terms of pollinators, again, all of the work that's been done looking at that suggests that it's not a concern, but you never know. There could certainly be some outcomes, and what I've been describing today hasn't been done at large scale. And so I think it's really worth monitoring what those inadvertent impacts might be. And I think the key area where we really do want to look is so it's getting accumulated into the leaves, right? And then those leaves are dropping. And so the residence time is not very, very long in the leaves, and there's not really a high level that's left by the end of the growing season in those leaves. But does that have some impact when it goes back into the soil and gets cycled through? Again, the limited work that's looked at it suggests no, but it's limited work. So I think there needs to be a little bit closer look at that to fully conclusively say this is benign. But in general, woodpecker, the fact that the insects are dead is a good thing, and that most everything else doesn't want any part of them.
Awesome, Tony. Well, thank you so much. And there's lots of really good questions that have come into the chat box or the question box. And as you said, sort of lots of continued research and conversation to be had on this topic. So again, we really appreciate you taking the time to join us today, to provide such a thoughtful approach to thinking about preserving ash in the landscape. And you've given us a lot to chew on. One last question and maybe a request. I've had a few folks who have asked for copies of your slides. Is that something that you'd be willing to make available to folks who
yeah. Absolutely.
Okay, perfect. So I will, yeah, if you want to send those to me, then I'm happy to send those out by email to everybody on the webinar today. So again, with that, thank you, Tony, so much for joining us and for providing all this information and for starting this conversation. It's based on the questions that have come in. It's clear that that we need to continue to review this topic and maybe have you back for a future webinar.
Yeah, but you can all blame me for the foolish ideas that started what hopefully become really good ideas. So.
Excellent. Well, thank you again. We seems like all good ideas to me. But again, we appreciate everybody for taking the time to join us and tuning in to this important topic and for continuing the conversation out there. So thanks again, everybody, for participating today. A reminder for folks who are looking for continuing education credits, please go ahead and close out of the webinar. You should get a pop-up window from GoToWebinar with a request to fill out a survey, and that's where you can let us know if you'd like a certificate of attendance, and if you're an SAF member, we will process the CEU requests directly. So with that, I'm going to go ahead and say thank you and appreciate everybody's time and participation in the webinar today. Thanks, everybody. And again, Tony, have a great day, everybody.